So let's try and get to the core. Maybe you could simplify it for us and explain what exactly is transcranial photobiomodulation.
Well, a big part of that word, if we take this transcranial off and stick with photobiomodulation, kind of goes like it's evolved to that being the term that we're trying to use today. I mean, when I got involved in laser therapy in the late 90s, we're still using words like cold laser and low level laser therapy. And so the biggest thing for people to understand is that we're using laser energy at a very low setting power wise that is biostimulatory versus someone was getting, say, surgery with a laser.
Yeah.
And the World Association for Laser Therapy and also NALT, which is North American Association for Laser Therapy, decided several years ago, hey, listen, guys, we need to come up with a term that kind of encompasses what we're doing with lasers at this lower level of energy. And so they come up with this photobiomodulation term because you could even look up transcranial older studies and they'll use low-level laser therapy because you're using energy that is in the milliwatts versus, super high wattage. And, with transcranial, we're talking about literally shining light into the brain via passing through the skull itself. And it has to be a certain wavelength. We can't use, red laser will stay in the scalp, but infrared will penetrate and go in the brain. And we didn't know any of these things were possible until the early work by acupuncture research in the late 70s. Where they actually were using red laser on actual acupuncture points on the head. Mm-hmm. And from that, they're like, there's a lot more going on here than we think besides stimulating acupuncture points and affecting the brain. And somehow that morphs into infrared lasers not long afterwards. And we started seeing the effects in acupuncture. And it took a while until we really had some people put together devices that could treat, various parts of the brain, not just one little area or one little acupuncture point.
Yeah, it's really amazing that you look at something like light that we see all around us and we think that can penetrate the skull. We know how hard this noggin can be. and yet infrared, right, is that type of wavelength that goes. Now, how deep are we actually penetrating into the brain?
Well, a suggestion from the research is looking at about 1 to 4 centimeters.
Okay. And with that 1 to 4 centimeters, what's happening within the brain?
Well, and that's the fun part. So as these studies keep going forward and looking at what's taking place, I mean, the simple thing is that one, we know that our bodies can absorb light, and we came from light. And at what place we first begin with is looking at a level within the cell where your cell creates energy. And the battery of the cell called the mitochondria. And there are various, what we would call complexes that are in this mitochondrial membrane that can absorb various spectrums of light. And from that, we then went forward. What happens next? So it's not just about the mitochondria. Initially, we would kind of hang our hat on and say, well, we're enhancing the cellular energy at a cell level via the mitochondria, and therefore the processes within the cell will work better. That was kind of simple way of looking at things. Now, over the last 15 years of research, we're in a far different place because now we know that we're also affecting blood flow. So we can increase the blood flow throughout the brain, and that's going to lead to better oxygenation at the cellular level. And oxygen is also how our mitochondria, our batteries, our cells make energy. We also know that we're affecting the lymphatic system of the brain, or the lymphatic system is a more precise term they're using for the brain. So we're actually affecting the way the brain moves fluid around. And we could also add to that they will also affect the way the brain is detoxifying. There's also some possibilities of increasing in people who have, say, vascular disease of the brain, and which can lead to dementia. People have had many strokes. People have had aneurysm would be a larger, bigger picture of a hemorrhagic stroke. We want to be able to, especially if it's ischemic, so lack of blood flow, and we would be able to increase the ability to grow new vessels. So something called angiogenesis is another thing that we're saying has been affected. And then also at a neural level within the brain there's two terms. One is synaptogenesis, one is neurogenesis. So you're actually able to enhance the neurons within the brain, maybe even help ones that have been damaged, say from traumatic brain injuries like a concussion or a stroke. And at the synapse level, where our neurons are communicating with each other on both sides, we can affect those synapses.
Hmm.
I got one else going with that. No, that's pretty much everybody that I know of. I mean, there. And here's the thing. I mean, if we've all been in medicine long enough and doing this, we don't really know a whole lot. And I think it's really important people understand that. I mean, I don't care if you're a naturopath or you're a brain surgeon. There is obviously, a different specialty is taking place there. But the reality is, there's so much more that's unknown about how the body operates and how it works. And then we can toss on top of all this how you use this type of science with frequencies.
That's right. Because that's a big part of it too. It's not just the lights itself, it's frequencies, which I want to jump into in a little bit.